Right, and here is my solution to part B of question 7. So again, we've got a similar setup, W, X, Y, and Z, A, B, C, and D. And we have to go through the same process again, and that is to start by doing our row reduction. That's step 1. So the first thing I'm going to do is pick my lowest number in each row, 2, 3, 2, and 2, and operate that row reduction. I can see some really interesting numbers. They're quite close here, so I'm seeing that this might potentially lead to some sort of, not necessarily a trick, but it might just work out weirdly later on. So let's see how we go. So the first row, subtract 2 from everything. I get 0, 2, 1, and 3. Subtract 3 from everything in the second row. I get 0, 2, 0, and 2, and 1. Simple maths there. I'll subtract 2 from everything in row Y. I get 0, 1, 2, and 0. And subtract 2 from everything in row Z. I get 0, 2, 0, 1. Close that bracket off. And now I'm going to have a look and see if I can cover all the zeros in less than 4. And I can cover there, there, and there. Job done. Or I could do it this way. There, and there would also work. So that would be covering in less than 4. So I'm going to move on. Step 2. I can't finish yet, in other words. Now I'm going to do my column reductions. So I go through each of these. I might rub out my, I'll leave the yellow highlight on there. And in blue, I'll go through and highlight all of my lowest values in each column. In the first column, I've got a heap of zeros. And so that's not actually going to change. In the second column, I've got a 1. In the third column, I've got a 1. Oh, I've got zeros, sorry. I've got zeros. In the fourth column, I've got zeros. So this time, my first column will stay as zeros. My second column, I'll subtract 1 from each. So that's 1, 1, 0, 1. Third column, I'll subtract 0 from each, which means it stays the same. And the fourth column, I'll subtract 0 from each, which means it stays the same. And I'll close that bracket off. Now I'll have a look again. Can I cover in less than 4? And I can cover 1, 2, 3. So again, this just comes with practice. You get to see the coverage working out for you. So now let's look at step 3. And this is where I get my coverage from step 2. I highlight, and I'm going to circle these in purple, my double covered numbers, which in this case is 0 and 2. 0 is covered by this guy and this guy. 2 is covered by this guy and this guy again. And I look at my uncovered values, and I determine my least uncovered value, which in this case is 1, and it occurs several times. So I subtract 1 from every uncovered value, but I add 1 to every covered value. So it's going to look like this. 0, 0, 0, 0, 0, 0, 1, 0. They're all my covered once values. So that is these guys, this guy, this guy, this guy, this guy, and these guys. They're all covered once, they don't change. These two are my covered twice, so I add 1 to that, I add 1 to that. And the rest are uncovered, so I subtract 1 from each. 0, 0, 0, 0, 0, 2. Now look at the numbers I've got left. I'm guessing that I pretty much have got every multiple ways of covering with 4, but I don't think I'm going to cover with 3. There's too many numbers that are zeros now. So I'm going to try and knock out rows of 4. There's 1, there's 2. That's maximum knockage. I can do that to cover out 2 more, but I've still got this guy and this guy. So I can't, that's not even the best way. The best way here is to cover with 4 by forgetting these. Just swapped out that 0, but literally just to go there and there. And I have to cover with 4 that way. So I'm at the point now where I can cover with only 4, but I can't cover with less than 4. So therefore I'm finished. And now I need to turn this into a bipartite graph. So I go back to my labels, W, X, Y, and Z, A, B, C, and D, and I'll create that bipartite graph. W, X, Y, and Z, A, B, C, and D, where every connection is based on the zeros that are available. And I'm a bit worried. There's a lot of zeros here, so it's going to look really messy. So I'm going to use colours. W connects to A and B, so in green. X connects to A, B, C, and D. Y connects to B and D. And Z connects to all of them as well. So basically I've got Z connects to 3, D connects to 3, C connects to 2, B to 3, and A to 3, B to 4 and A to 3. So that doesn't help. I can't close anything down. I've got the same with W, X, Y, and Z, although W and Y can connect to only 2 each. So what I've got choice here, and I'm going to look at my choice and look at options, and there's going to be, I think, multiple pairings. But the first answer, the first obvious one, is to consider, well, W's only got 2 choices, so let's start by just picking one, and if I pick B, I can see that that forces Y to match with D, because Y can only be B or D. So that's why the colours have been really good. So if W is B, I'll put a little if, then Y is D. And if Y is D and W is B, that means that X and Z have to be A or C. And X and Z can both be A or C. So therefore I've got X is A, Z is C. Or W is B, Y is D, X is C, and Z is A. So there is 2 options, and then I've got the other or, which is of course, what if W is actually A? If W is A, well, that doesn't actually close anything down anywhere else. So now I've got a choice with Y. Y can still be 2 things. So let's Y be B. It's pretty boring. And if Y is B, then Z and X have to be C or D. They can both be C and they can both be D. So I get X is C, Z is D, or W is A, Y is B, X is C, X is D, my apologies. Z is C. So there's multiple options for the minimum here, which makes this one a little bit more confusing. Now I'm doing this with W as A. I've still got more with W as A because last time I chose if Y is B. So what if Y wasn't B? What if Y was D? W is A and Y is D. This crosses out D and A. X can be B or C, and Z can also be B or C, so I've got 2 more. Let's go X is B, Z is C, W is A, Y is D, X is C, Z is B. There's my 6 options, and you'll note there how I've gone through in a systematic way by looking at, I've chosen to look at W and then Y because they're the ones with only 2 options each, and going, okay, what if W is B? Well, then I've got these 2. Okay, yep, okay, what if now W is A, and then Y has a choice, so let's make Y B, and I've got these 2. And then I go, well, okay, what if W is A and Y is D? And then I got these ones. So it's a very systematic way. And you've got to read the question, of course, because if I go back up to the question, this question actually said, find the minimum cost given the matrix and give a possible allocation. Here the question is only asking for a possible allocation. So I just pick my first allocation. They should all be the same. W is B, Y is D, X is A, Z is C. And I'll highlight that on here. What about the highlighting? W is B, Y is, I've forgotten it already. Y is D, X is A, and whatever the other one is. X is A, Y is D, Z is C. And when I add all those up, I get 4 plus 3 plus 11, no, plus 2 is 11. So minimum cost 11. I've put $11. Is it in dollars? I don't even know if it's in dollars. Anyway, 11 something. Now let's just to confirm, let's look at a couple of other options. So let's look at this one and this one, just to pick random ones. W is A, Y is B, X is D, Z is C. W is A, y is B, x is D, z is C, would give us 2 plus 3 plus 4 plus 2, 11. Surprise, surprise. And let's have a look at the other one. A, and then D, and then B, and then C. A, D, B, and C. So we've got A, D, B, and C again. Z is C a lot in all the choices I'm making. 2 plus 2 plus 2 plus 5 is 11 again. So we've got 6 ways of getting a minimum cost of 11. And just a note here, as I was sort of talking about the observation earlier, these numbers are all small and they're similar. And I'm kind of expecting to get multiple answers if they're small and similar. Up here, the numbers varied quite significantly, and we had some odd numbers in here, which indicates you're probably going to have a single answer or very few answers. Okay, I hope that's really helped, and all the best.